Hi friends, welcome to Civil Architecture Tutorials. Today's subject is VAV system or Variable Air Volume System. So this is a particular type of ventilation system in which the volume of air will be different, maintaining a constant temperature of the air. And this is being used in ventilation purpose of modern offices. So previously we are using constant air volume, that is CAV system. So now it has been changed to VAV system, variable air volume system, because this is more energy efficient than the previous CAV system. So let us go deep into this. As you know, AHU is called air handling unit, which we used to see when we are making an office. Before doing the false ceiling, you can see a very big machine like thing on the top of the roof where they will hang this thing there. So this is air handling unit through which it will suck the air from outside and it will cool the air, and then it is connected to a duct called supply duct. The supply duct that you can see over the false ceiling, that is like this. This is the AHU, air handling unit. There will be a fan here, and from there the cold air will go like this. This is a supply duct, and from this supply duct there will be divisions into the room. This is one room, this is the second room. So in this room there are three divisions, and the end part is called diffuser. So inside the room you can see the diffusers from which the air is coming into the room. Okay, you can hear the sound also. And there is one other grill called return grill. So that will take the air from the room to the AHU unit. So one is supply and the other is return grill. Supply is called diffuser too, through which the cold air will come. So how they are maintaining is that, so this is system, the supply air will go like this. So in office, if it is there are rooms of 6 or 7 rooms, suppose. So in one room we need a cold atmosphere. In the other room we don't need that much cold, and the third room maybe nobody is occupant and we don't need anything there. So in such case, that's why this VAV has been developed. Otherwise all the rooms will get cold. In the constant air volume system, all the rooms will get cold. Even if there is heat load inside it or not, all the rooms should be cold. So that system is not practicable because it takes a lot of energy. Now in this system, if it is 6 rooms are there, and this 6 rooms demand different types of air volume, not air temperature, it is possible. Some rooms can be hot, some rooms can be cold, depends upon the occupants. And you know, there are several factors which adds to the occupant heat load, that is the number of persons. If the number of persons in a particular room is very high, it will add to the heat. And if there are a lot of servers or computers in a particular room, when they are working, that also will add to the heat. If that particular room has got a glazing or a glass surface through which the sun rays can come in, that itself will make the room hot. That also you know. So there are a lot of factors. If the sun is facing that particular room will be having more temperature when compared to the other room. So many factors are contributing to the heat load of a particular room. So because of this, some rooms need more colder air than other rooms. Maybe the other room may be in a shaded region where there is no sun, so it doesn't need that much colder air when compared to this room. So these are the factors for that. So let us see the difference in it. What makes the VAV system a VAV system is it has got a VAV terminal, that is variable air volume terminal, which is absent in CAV system, absent in constant air volume system. So this is called VAV system. Means before the diffuser there is a small box like thing. Here I didn't show it, but before the diffuser, inside the false ceiling, there is a box like thing like this. This is a VAV box or VAV terminal. Okay, and from there the diffuser comes like this. So this is you can see a closer version of this VAV system like this. It's an open VAV system. From here the supply air will come, and see this one is this one. This is a circular opening, and there's a circular thing which will rotate like this. It's a metallic sheet. It's called damper. Okay, damper. And this damper and this circular thing, this damper is connected to an actuator, and actuator is connected to a controller. So actuator has got a shaft. So in the actuator there is a small motor which can rotate the shaft, and when the shaft get rotated, this damper will also get rotated. So the connection for the actuator is in the controller. There is another small equipment there which is called controller, and this controller is connected to the thermostat which is situated inside the room. You may have seen the thermostat in all the rooms, through which we can control the temperature in that particular room. If it is set for 24 degrees Celsius, we have to set it to 24 degrees Celsius. So the thermostat will keep that 24 degrees Celsius throughout the air conditioning time. Till we need the room to be air conditioned, it will keep the constant temperature as 24 degrees Celsius. So how it is attained is that the thermostat has got a sensor which can sense the temperature or heat inside the room. So if it is below, if it is going below or if it is going up 24 degrees Celsius, it will send a message to this controller here, and the controller, with the help of actuator, it will control the movement of this damper. See, this is the direction in which the damper is fully open, like this. So if it is like this, it is slightly closed. It will go like this because this circular thing will fully closed by this circular metallic sheet. Circular hole will get fully closed by this circular metallic sheet if it is closed like this, but it will never close fully, because whatever be the temperature difference, there will be should have a constant fresh air supply into the room. So in order to maintain that, the damper will never be closed fully. So when the room demands more cold air, then the damper will be like this in the horizontal direction, so that maximum air will come inside the room. If it demands a lesser cold air, then it will go like this, so that it will allow less colder air to go inside the room. So that is the system. So before that, I want to tell one more thing is that this system, I told, this is supply duct and this is the return duct. So from the return air it will go through this return grill, and it will go like this. In some of the system, this return grill, before the AHU, which I didn't show here, before the AHU, this return grill will have a connection with the air which is coming into the AHU. The duct which takes out the air from outside into the AHU, there's a connection between that duct to the return duct, so that whatever be the air inside the room will again be recirculated into the AHU. That is one system, but it will depends upon whether the local regulation will allow it or not. Usually it is we are not doing that, but there is a system like that too. Similarly, in VAV, in some cold countries, or maybe even at winter time also, we can go for a VAV terminal which is assisted with fan assisted, which is called fan assisted VAV terminal. So this is usual VAV system. Okay, now we will explain more into it. So I told that the temperature recorded by the thermostat will send a message to the controller, and it will control the air supply of the cold air supply with the help of closing or opening of damper. Okay, that much I think you understood. Then after this, there is this thing is called a heater, that is also present in a VAV terminal. So VAV heater, it can be an electric heater or it can be supplied by a hot air pump. Okay, but usually it is by electrical system, so that it is very easy to heat it up and to make it cooler also. So when in winter season we need hot air, not cold air. So as the air passes through this system, and when it passes through this heater, it will be when it passes through the heater, it will be hot. Then the hot air will come through this, and so this system is the usual system that we are using it in our offices. But in some other cases, the VAV is assisted with, like I said before, fan assisted VAV is also there. Let us see what is happening there. So this is the usual VAV system, but this is there is a attachment of this fan with a filter to this system. This is a fan which has got a filter too. Here what is happening is that this VAV is taking the room air again into it through this fan. So there will be filter there, it will filter out the impurities in the air, and then with the help of the fan it will again take the air directly into the heater, so that the VAV system can keep a constant volume of air, and also it can reduce the demand of heat for this heater. So in order to save the energy, we are using like that. So we don't need to heat more the colder air, because we are providing the hot air itself, which is already present in the room through this fan exit system, so that the heater should not take that much energy if there is no hot air. That is the second system for this VAV system. I hope. And there is one more thing I forgot to say. This is before this damper, there is one more section here, like this. Here there is a cross section like this. This thing is also there. This particular small cross like structure. Why is that? This is a pressure sensor thing. This thing will sense the pressure of air going through it. So as you know, the pressure of the central part of that system will be high when compared to the pressure of the side air. So it will sense the pressure also here. And regarding the pressure, I will say one more thing. See, this is the entire system. So there is a fan inside the AHU which will supply the full air into the full duct system. Okay, the supply air is being totally controlled by the big fan inside the AHU system. So there is high chance that there will be a pressure difference in the supply system, because in some rooms, if all the rooms need cold air at full time, if there are 6 rooms there, and if all the rooms need the fresh or the cold air supply throughout the day, the fan may not handle the system, because it have to work at full speed the full time, which may not be needed at all the time, because if there are 6 rooms, some of the rooms may not be occupied. So in such cases, there is chance for a pressure variance. So in order to avoid such a pressure variance, if the pressure variance is there, then the diffuser will have less supply of air. So in order to avoid such a system, we are placing a pressure sensor at the end of this supply duct. You can see here, the end of this supply system, there is a pressure sensor there. So it can dictate the minimum standard pressure which should be always present in the supply duct. So if it goes down, this will give a message from the pressure sensor to the variable frequency drive which is present in the AHU VFD. So it will give a message to the VFD, and the VFD again will tell the fan to increase its running capacity or increase its pressure. So the fan will increase the pressure, and it will keep the pressure, or it will maintain the pressure inside the supply duct. So these are the system through which the modern office ventilation is working nowadays. And the main advantage is that it can help to reduce the energy level when compared to the constant volume of air which was traditionally used before. So I hope you understand the VAV system by this video. I will come with a new subject in a new video. Till then, goodbye. Please subscribe, share and like my channel. Thank you very much.